Good evening, doctor. My name is Mathan. So today I'm going to present part 1C for the LAB3, and then this will be the program 1. So let's get started. So we start with include rewind 32.inc. So we move to the next, where this is the dot data, where it indicates the data type segment, where we need to assign the variables with the data types and the value it represents. So the first one will be the site hex1, then the second one will be the site hex2, and then the third one will be the perimeter underscore hexagon1, and the perimeter hexagon2, and then the total perimeter, which is the data type of the 5 variables are D word. So we move to the next data type. So the first one is prom1, and then the second one is prom2, result1, result2, add sign, and then total perimeter message, and then the end line. So there are 7 variables here with the data type byte. So the first one will be with the values it represents is 0 here. Then this one will be the 0 in decimal, and then this 0D in hexadecimal. Then this one is the 0A with the value of hexadecimal. So we start with the prom1, which is the data type is byte. So this will be the string. So there are, as you can see here, there are 5 strings here. The first one will be the prom1, which is enter site value for hexagon1. The second one will be the prom2, enter site value for hexagon2. Then the result one will be the perimeter for hexagon1 with the site equals 2. And then the second one, and the fourth one will be the result2, where the perimeter for hexagon2 with the site equals 2. And then the add sign with is the total perimeter message with the total perimeter is equals to. So we move to the next one, where we're gonna move to the code dot code, which is a code segment. So we start the code segment with the main PROC. So let's start with the first one, where we need to get the site length for the hexagon one. So to get the site length for the hexagon one, we're gonna move the offset of prom1 into EDX, and then following it, we're gonna call the write string, and then we're gonna call the read integer. So the next one will be we're gonna move the value of AX into site x1. So we move to the next. So the next one will be the get site length for the prom2. So this one will be for the hexagon2, where we're gonna move the outside of the prom2 into EDX. Following, we're gonna call the write string. Then we're gonna call the read integer. So the next one will be we're gonna move the value of AX into the site x2. So both these to get the value of the length for the site length for the hexagon 1 and hexagon 2. So we move to the next, where we're gonna calculate the perimeter of hexagon 1. So to get started, the first one will be like this, where we're gonna move the value of 6 into ECX. This is important because we're gonna create the looping process, where it needs 6 times we're gonna make it. So that's what the 6 value is indicated. So we move to the next, where we move the value of site x1 into EX, and then following that, we're gonna move the value of 0 into EBX. So to calculate the perimeter of hexagon 1, so we're gonna add the value of AX, EAX into the EBX, and then we loop the we're gonna do the loop. So the loop calculate perimeter x1. So the next one will be we're gonna move the value of EBX into the perimeter underscore x1. So we move to the next one where we're gonna calculate the perimeter of x2. This is the same one as the previous where we changed it with the hexagon 2. So the first one will be as we all know we're gonna move the 6 into ECX. So as this is the important thing to create the looping process. So the next one will be we're gonna move the value of side x2 into EAX, and then we're gonna move the value of 0 into EBX. So to calculate the perimeter of hexagon 2, we're gonna add the value of EAX into EBX. And we're gonna do the looping process. So loop calculate calc underscore perimeter underscore x2, and we move the value of EBX into the perimeter underscore x2. So the next one will be we're gonna calculate the total number perimeter. So where we're gonna calculate the total perimeter of hexagon 1 and hexagon 2. First one will be we're gonna move the value of perimeter hexagon 1 into EAX, and then we're gonna following it we're gonna add the value of perimeter hexagon 2 into EAX. And then the next one will be we're gonna move the value of EAX, the sum of value into the total perimeter where we will get the total perimeter from the perimeter of hexagon 1 and hexagon 2. So the next one will be we're gonna display the perimeter of hexagon 1. So to display the perimeter of hexagon 1, we start with we're gonna move the offset of result 1 into EDX. Following it, we're gonna call the right string, and then we're gonna move the value of side x1 into AX, and then we're gonna call the right integer. The next one will be gonna move the offset of h sign into EDX. Following it, we're gonna calling the right string. Then the next one will be we're gonna move the value of perimeter underscore 1 into AX. Following it, we're gonna call the right integer. And then the last one will be calling the CRLF. So we move to the next, where we're gonna display the perimeter of hexagon 2. This is same as the previous one. So we start with the first one where we're gonna move the offset of result 2 into EDX. Then the next one will be we're gonna call the right string as usual. The next one will be we're gonna move the side x2 into EAX. Then the next one will be we're gonna call the right integer. And then we're gonna move the offset of h sign into EDX. Then we're gonna call the right string as usual. Then we're gonna move the value of perimeter hexagon 2 into EAX. And then we're gonna call the right integer. And then the last one will be we're gonna call the CRLF. So we move to the last part where we're gonna display the total perimeter of hexagon 1 and hexagon 2. This will be the sum up value of perimeter of hexagon 1 and hexagon 2. So we start with this. We're gonna move the offset of total perimeter message into EDX, and then we're gonna call right string. And the next one will be we're gonna move the total perimeter into EAX. Then we're gonna call the right integer, and the last one will be the CRLF. So after this, we're gonna exit the program, and then the main ENDP. So to end the main program, we're gonna end it now. So this will be the program one. So I'm gonna test it where I'm gonna debug the thing. So we debug it first. So as you can see here, this will be the output. We're gonna check it. So for the first one, we're gonna enter a site value for the hexagon one. So let's say I'm gonna enter the value 5. So the next one will be we're gonna enter a site value for hexagon 2, where we're gonna add 4. Where we enter. So let's see the perimeter for hexagon 1 with the site value of 5 is 30, and then the perimeter for hexagon 2 with the site value of 4 is 24. And then the total perimeter, which we sum up the value of uh, x1, we sum the value of hexagon 1, perimeter hexagon 1 and perimeter hexagon 2, and then we got the answer 54. So for this thing, I'm gonna do the example with another value. So let's try it. So now I'm gonna enter the value for site value for the hexagon 1, 11. Then the second one for the hexagon 2, which is 12. I'm gonna enter 12. Then let's see. The perimeter for hexagon 1 with site value of 11 is 66. And then the perimeter for hexagon 2 with the site value of 12 is 72. So the total perimeter of hexagon 1 and hexagon 2, we got the answer 138. So as you can see, this program is successful. So that's all for program 1, part 1C. Thank you. So good morning, doctor. Today I'm going to present uh, part 1C for the LAB3, and then this will be the program 2. So we start with the include Irvine 32.inc. So let's move to the next with dot data, which is the data segment. So let's get started with the data segment. So the first one will be the hello keyword, and then the second one will be the second one will be this, and then the third one will be the total this one. So this one is the data type which is keyword. So the first one will be the hello, which we declare the array hello with 6 keywords with the initialization 0. So the next one will be the total even with the data type keyword, and then this one is to declare the variable or to store the sum of even index. Then the next one is the total odd with the data type keyword. So we move to the next one, which is the string type. So the first one will be the input, then the second one will be the result even, the third one will be the result odd. So with the data type byte, and then this is the string. So the first one will be the enter integer for the input, and the second one will be the total even is for the result even. Then the third one is the total odd for the result odd. So we move to the dot code, which is the code segment. So we start with the main PROC. So to initialize the variable, so we start with we gonna move 6 into ECX, where we set the loop counter to 6. So there will be 6 number of inputs. So the second one will be the LEA ASI hello, which means we load the address of hello into ASI. So the next one will be the loop for input. So where we start the looping. So the input for the loop is we're gonna move the offset of input into EDX, and then following with we're gonna call the write string, and then the next one will be we're gonna read the integers input by user, where the first one will be we call the read integer, and then the next one will be we're gonna move the EAX into the AIS. So this means we store the input in the hello array. And then the next one will be we're gonna add the value of 4 into ASI. And then the next thing is called CRLF. So the next one will be we're gonna do the loop for the input loop. So we're gonna repeat the same thing for 6 times. So we're gonna move to the next one where we're gonna reset the pointers and counters. So the first one will be LEASI hello, which indicates we're gonna reset the ASI to the start of the hello array. Then the next one will be XOR EAX, XOR EBX, XOR EDX, which means we're gonna clear the registers. So the first one will be XOR AX into AX, which means we're gonna clear the AX register, and then the next one will be XOR EBX, which represent we're gonna reset the. We're gonna clear the EBX register, and then the next one will be XOR EDX. We're gonna clear the EDX register. And then the next one will be move value of 0 into ECX, which also we can say we're gonna clear the ECX register. So we move to the next, where we're gonna do the loop through hello array to calculate the total. So to calculate the total, we're gonna move ESI plus ECX multiply with 4 into EAX. So which means we're gonna load the value from hello array and index ECX into EAX. So the next one, the test ECX one, which means we're gonna test if the ECX is odd or even. So the next one, we move to the next one where JZ is odd, which means you check if it's odd or not. So if ECX is even, it will jump to is odd. So we move to the next one where we're gonna add the value of AX into EBX. This one is to check if the ECX is odd. If it's odd, we add the value of EX into EBX. Then the next thing we do is we jump to the next element. So the is odd thing, just now I already mentioned, where we add the EAX into EDX if the ECX is even. So the next element will be INC ECX, which means we increment the loop counter of ECX, where initially we set 6, so we're gonna increment that. So the next one will be CMP ECX6, which means we're gonna compare the ECX with 6. And then the next one will be JL calculate total, which means we jump to the calculate total if the ECX is less than 6. So later the looping, this is the looping that I said just now. So the next one will be the store result in variables. So the first one will be we're gonna move the value of EBX into total event. Uh, so the next one will be the move the value of EDX into the total odd. So where we move the sum of even and odd index numbers into the total even and total odds. So the next thing will be the display result where we're gonna display by this. We start with we're gonna move the offset of result odd into the EDX, and then as usual we're gonna call the right string, and then we move the total odd the value of total odd into EDX, and then we're gonna call the right there, and then we're gonna call the CRLF, and then the next thing will be we move the offset of result even uh, into the EDX, and then as usual we're gonna call the right string. Then the next thing will be move total even into EX, and then they call the right drag, and then the last one will be called CRLF. So this one I'm gonna exit the program now. So exit and then main ENDP, and then end main. So this will be the program 2 for part 1C. So let's check it how it works. So we're gonna see the output. So as you can see here, we're gonna enter an integer. So let's say I'm gonna enter 32. So this is where the looping starts. The first looping is 32, and then the second one will be enter integer again. I'm gonna enter 65. Then the next one will be the same thing. I'm gonna enter 77. And then enter integer again for the fourth time, where I'm gonna enter 89. Then the next one will be the integer is 14. And then 54. And then we got the total odd is 123 in the sum value of odd numbers in these integers, and then the total even is 208, and this indicates the sum value of even numbers in these integers. So let's say we're gonna test it again with the different integers. Let's see. We try with the three digits number, 3 to 4 digit numbers. So the first one will be I'm gonna enter 1145. And the second one will be 345, and then the third one will be 234, and then 132, and then 344, and then 654. So now you can see here the value of total odd is uh, 1723, and then the total even is 1122. So as you can see here, our program is successful, and then I think that's all for program 2 part 1C. Thank you.
Hi, Doctor. I am Tanliji from the session 4 COF class. So now I will explain the lab 3 part 2C. Okay. So, okay, for the dot data here, this R is the string detailer that we want to display to the message to the users. So we can include the menu 1, menu 2, menu 3, menu 4, and also prompt 1, prompt 2, prompt 3, hexagon results, which is the result of the parameter hexagon 1 and 2, and then the total parameter, sum of prompts, integers input, result of the sum, and then the result of the even, and result of the odd, and then yes, no, by an invalid message here. So the below one here is the variables that need to store the value or the input by the user. So we have the size has 1, size has 2, parameter hexagon 1, parameter hexagon 2, total parameter hello, which is the array that has 6 element, and a sum even, and then some odd, selection, and yes no choice, yn choice. So let's go into the main code. So the main menu here, we have to call CLR. SCR is the clear screen. So you need to clear screen when it reach the main menus. So the next is move the offset of the menu into EDX. So we need to call the right string. So you will display the output of the menu here, string literal menu. Okay, you will right string mean you will output the display. And then next we move the offset of the menu 1 into EDX. So you will call the right string also, display the output for menu 1. Same goes with the menu 2, menu 3, and menu 4. Okay, for the call rate char, so you will read the character that input by the user, and then call right char, you will display the input by the user. And then we move the ALL is a register, is the lower of the register EAX. You will move into sections, and then call the CRLF is the new line, mean it will make a new line, and then we need to compare the selection, the one. Okay, if the selection is equal to 1, it will jump to perimeter head loop. Okay, and then we compare the selection with the 2. If the selection is equal to 2, it will jump to the count sum of even. Next, if the two value is not equal, so it will jump to invalid input. Okay, invalid input as shown here. So next we will move the offset of the invalid into EDX. So it will also call the right string, it will come out with the invalid message here. So make a new line, then after this it will jump to the main menu again. Okay, next is a perimeter head loop, which is this one. So when the selection is equal to 1, it will jump direct to here, and then it will clear the screen again, and then it will move the offset of the prompt 1 message into EDX, so you come out with the message prompt 1 because of the call right string, and then same goes with this one. Okay, move offset of the prompt 2 into EDX, so it will call the right string, it will sort out the message to the user. Okay, then call the rate def, so it will read the decimal value that input by the user, and then we'll move the EAX to site hash1, so it will store the value that entered by the user into site hash1, and then it will move also the offset of the prompt 3 into EDX, so it will call right string, it will sort out the message of the prompt 3, and then call rate def, it will read the decimal value that input by the user, and it will move the EAX to site hash2, so it will store the value into site hash2. So now we need to calculate the parameter for hexagon 1. So we move the site hash1, which is the value just stored, into the EAX. So we will move the 6 to the ECX register. So 6 means the loop we need to have, because the hello array has 6 elements inside. So the XOR EDX means that you will clear the EDX into 0 and to 0. So continue with has one loops. So you will add the EAX with the side H1 into the EDX. EDX is beginning with the 0, uh, and then store the value in the EDX also. So you will loop the hash one loop again until it reaches the sixth loop. And after that, you will move the EDX into perimeter hexagon 1. Okay, so this will store the perimeter of hexagon 1. Then we calculate for the perimeter for the hexagon 2. Same goes. You will move the side hash 2 into EAX register, and then you will move the 6 into ECX. So you will have the 6 loop, and then XOR EDX. So it will clear the EDX into 0. And then for the hash 2 loop, you will add the EAX to EDX register. Okay, and then you will loop again with the hash 2 loop until you reach the 6th loop. And then we will move the EDX into perimeter hexagon 2. You will store the value into perimeter hexagon 2. Okay, so we need to calculate the total perimeter. So we move the perimeter hexagon 1 into EAX. So we add the perimeter hexagon 2 into EAX again. So uh, next, you will move the EAX into total perimeter. So the total of the perimeter hexagon 1 and total of the perimeter hexagon 2 will be stored in the total perimeter here. Okay. Next is the display result. So we move the offset of the hexagon result into EDX and call the write string. We will sort up the hexagon result. Then here in a new line, I come to a new line. So next, perimeter for hexagon 1. So we move the perimeter hexagon 1 into EAX. Okay, so it will call the write diff, which also sort out the perimeter hexagon 1 there. Okay, then it will make a new line, and then same goes with the perimeter hexagon 2. You will move the perimeter hexagon 2 into EAX. So it will call write def, so it will sort out the decimal value of the perimeter hexagon 2. Then we'll make a new line again, and the total parameter. So we move the offset of the total parameter into EDX. So call write string again. So we will sort out the total parameter message here. So we move the total parameter into EAX and then sort out the decimal value. We can use the call write that here and then call the CRLF in new line again. So we want to ask if the user want to continue or not. So we jump to the select menu. So select menu, we offset the yes no into EDX, yes no message into EDX. So we call the write string which sort out the yes no message. Then we call the read char. Okay, read char mean it read the user input and then call the write char. So it will sort out the character input by the user, and then move the AL into YN choice. So uh, it will um, it will move the register AL into YN choice, and it will call the CLF 2 times to have two new line into two new line, and then compare the YN choice. Y If the YN choice is equal to Y, it will jump to main menu. If the YN choice equal to N, it will jump to the exit program. So for the call sum or even, okay, so it will call the CLR as CRE clear screen and then move the offset of the sum prompt into EDX, and then call the write string. It will sort the sum prompt message to the user, and then it reads 6 integer into hello array. So it will move the 6 into ECX. Okay, this for the 6 loop, and then uh, move the offset of the hello into ESI. So we all know that hello is array, so we need to have a new address here. Use the ESI effective memory address here. So for the sum input loop, we move the offset of the integer input into EDX. So write string here. So it will come out with the integer input message. So we call the read that. So it will uh, read the input by the user in decimal value, and we move the EAX into ESI. Okay, so we add the 4 into ESI. So mean that one of the element in the hello array, okay, has 4. So we need to add the 4 into ESI. Mean that the next element in the hello array. So we loop again with the sum input loop. So we'll loop until 6 times. So we need to calculate for the sum even and sum odd. So XOR EAX mean clear to 0. EAX will be EBX will clear to 0 also. Then move the offset of the hello into the ESI. Okay, now we need to calculate the sum of the event index. So we move the 3 into ECS. Okay, why the hello here have only 3? Because you need to calculate for the event index, because event index in the hello address had only 3, which is the 2 which is okay in the array. It will say 2 element and second element, 4 element and 6 element, but in the assembly language it has to be hello in the 0 index, hello in the 8 index, and hello in the 60 index. Okay, so it will move the 0 into EDI, so reset the EDI. Okay, in destination. Okay, then for the sum even loop, you move the ESI plus EDI into EAX. So you move the ESI plus EDI, mean ESI is the hello index, EDI is the 0 first, and then it will jump to 8 and then 16. So then we add the EAX into some even. Okay, and then we also add 8 into EDI. Okay, why 8 into EDI? Because 8 is one element is 4 and 2 elements should be 8. So you add the 8 to the EDI. So you loop again with some even loop. So when this one is 8, so we add to the ESI. So it will jump to element. Okay, so same goes with the odd index. Move the 3 into ECS, move the 4 into EDI, because start with the 4 one element, first is one second element, so you need to start with the hello 4, and then the sum of loop, you need to move the ESI plus EDI into EAX, and then add the EAX into some of the odd numbers, odd index, sorry, and add the 8 into EDI, so also jump 2 element, so it will come to 4 plus 8 equals 12, 12 by x into 20. So loop again with the sum of loop until 3 times. Okay, and then display the result. You will move the offset of the result sum into EDX and then write string. So we will sort out the result sum. And then same goes with this one, even result. That already store the value, so uh, it will also sort out the even result to the user. and it will solve the sum of the event that just now store as a variable, and then you will write the decimal, which is sort out to user also the value, and then new line, same go with this one, op result, and then it will sort out the op result message, and you also will sort out the sum odd, okay, to the user. Okay, next you will ask to continue. You will jump to the selected menu, whether you want to exit or continue. So for the exit program, you will move the offset of byte to the EBS and then call write string. So it will sort out the byte message and then clear the line and exit the program. Okay. So now I want to uh, demo the code. So now let's debug. Start debugging. Okay. Then we will select the first one. Sorry, the first one, and then come to the perimeter to hexagon here calculations. So input hexagon 1, we will follow 21, and then the 32 for the input hexagon 2. So the value should be like this. The output should be like this. Okay, total perimeter hexagon 1 and 2 is 318. So we'll continue with the yes, and then we continue with the second function. Okay, calculate the sum of the uh, odd and even in the array hello. So we put the 20, 25, 30, 37, and 40, 43. Okay, so the sum of the hello even index is 90, and then sum of hello in odd index is 105. So we continue with no. So we will thank you bye. Okay, so thank you for watching.